A very good evening to all the viewers, and thank you for joining Minimac Mentonia webinar. Let me introduce myself. I'm Supreme Ranjan, Senior Executive at Minimac Systems, and your host for tonight, and your host for this evening. As you all know, our topic for the third webinar of Series 2 is Strategies for Monitoring Oil Degradation, Managing Varnish, and Fill4Life. Varnish is one of the most common types of contaminants in oil which promotes degradation and causes many kinds of equipment failure. Today, our experts will highlight the cause of oil degradation and effective ways to manage them. Making no further delay, let me introduce the panelists for today's interactive session. Mr. Anshuman Agrawal, founder and managing director of Minimac Systems Private Limited, and Mr. Guillaume Calvin, general manager of the Middle East and Africa at Fluidtech. Before handing over the session to our experts, just a brief of our webinar's flow. We'll start with the presentation of 1 hour, followed by a live Ask Me Anything for 30 minutes. So don't forget to drop your questions in the Q&A box and make sure you don't drop your questions in the chat box. Over to you, sir.
Thank you so much, Supreme, for inviting us today for this session, which is on a very interesting and innovative topic, and that's strategies for monitoring oil degradation, managing varnish, and Fill4Life. So certainly, oil degradation is a topic which interests a lot of lube professionals around the globe. A lot of people are still, not aware that oil degradation is something which leads to varnish formation and thereby sludge formation. So both of these topics go hand in hand. That's oil degradation and managing varnish. And it has been a known fact that varnish, sludge, oil degradation, they lead to reduction in oil usable life. So even if you have a lubricant which is guaranteed for a certain period of time by the lube manufacturer or the technology provider, it is seen in practicality that those lifespans are not reached out. So here we would like to talk about Fill4Life. Means whatever lube you have been using, it can be actually used for the entire life. And we would be talking about all of these together. I'm very honored that Mr. Guillaume Calfon is a part of this webinar, and he is the general manager at Fluidtech USA, organizations of the world having multiple patents and technology developments around this topic. Thank you, Guillaume, for joining us and being a part of this particular stage.
Thank you.
So I would set the stage for Guillaume. Of course, he's the champion on this particular topic. So initial few slides, I would set the stage for him, discuss with you what's varnish, and basically have a link from where we left in the previous session about varnish so that he can take it forward from there. So the step one for this entire understanding would be to first understand what's varnish. Now, varnish has a certain appearance, it has certain color. So many times that lube professionals or maintenance or reliability professionals around the globe, they do observe varnish, but they don't identify it as varnish. They might be seeing there is some kind of stickiness or some unwanted material which is getting deposited on their equipment, their surfaces, on the base of reservoir tanks, or any corners while you're doing some overall maintenance or some breakdown activity. You might see some substances which are not identified. You can say they're like a UFO, and you might be feeling that it's a part of the oil, and many times, or rather most of the times, we have been seeing professionals ignoring it or rather neglecting it, probably because they don't know that this substance, what they have seen, is certainly not not a wanted one or a part of the oil, but it's a reality that most of the professionals around the world, they start assuming that it's something which is a part of the lubricant. and probably they need not have to worry about it. So that's a big misconception which needs to be actually resolved. And hence, we are trying to explain you that the appearance of varnish can be any of these. It can be a sticky or a gooey material. It can be spongy. It might also be in form of a powder, because it's as we move on to the next slides on how varnish is formed, you would understand that it's some kind of hydrocarbon byproduct which gets produced because of certain degradation of oil, and hence it can take up any shape, any form, any appearance, and also any kind of color. So what is varnish? There are multiple definitions to it, but most of them talk about it's a soft contaminant. Also, it's some kind of an insoluble film, which does not get dissolved as it's insoluble, and it gets deposited on various surfaces. It's highly unstable in the oil because of its own molecular weight, which is quite heavy, and you are unable to remove it. By the statement that you are unable to remove it by standard mechanical filtration is because it's like a sticky surface which gets formed over the filters, over the mesh, over all these micron media, and thereby probably your filters will get choked up very fast. So these are some of the pictures we could collect from multiple sites. So the first one is probably a reservoir tank. It's one of the most common sites, I'm sure. And many of us use our conventional methods during the overall, just remove them off and we feel that, yes, the job is done. But in reality, we must get into the root cause of why this reddish kind of a layer has got formed in our tanks. It was certainly not there. We commissioned the plant, but right now, if it is present, certainly it is something which is unwanted, which has happened. And trust me, we must not say that, yes, if it's a lube system, it is meant to have it. That's the biggest misconception right now in the market. Then you also have some other critical parts like bearing parts and some shaft, which you can see here. So if you or any one of you or your colleagues has seen these pictures or similar ones, trust me, it's nothing else but varnish. Second, trust me, your mechanical filters or the OEM supplied equipment filters are totally incompetent to handle them. And that's why they actually got formed. So if this is happening, it is an alarm for you. Rather, it is more than an alarm for you, because if this is happening in your lube system, please believe me, something very bad is going to happen very soon. So what is varnish by definition? It's like a deposit from depleted antioxidant additives and degraded base oils. It is like a soft contaminant. So soft contaminant means it does not have metallic contaminants in it, but it's something which is too soft. It's jelly-like. Again, some of the pictures which you can see in a turbine oil system, in gearboxes, or in the thrust bearings. So these are not burnout of parts. Like most of us, when we see reddishness or brownishness in our parts, we feel maybe it has burnt out, but it's not that. It's actually varnish. So some understanding on what is the overall size that we are talking about. So the insoluble contaminant is around 0.08 micron in size. Certainly it can't be handled by any of the filters we talk about. And what happens is, as these are very sticky in nature, they form agglomerates. Agglomerate means a lot of such soft insoluble contaminants, they join together and they make a bigger one. But even when they are agglomerate in size, their size does not go beyond 1 micron. So it is certainly something which is extremely fine in nature, and hence regular conventional mechanical filtration systems can't handle them. Talking about the most popular ones, that's the centrifuge or centrifugal systems by many OEMs like Siemens and General Electric or BHEL. Many of the OEMs supply centrifuges along with this equipment. So certainly the centrifuges can't even detect or remove the varnish. So this certainly means that if your duplex systems of filters, if your centrifuges are not able to handle varnish, and still you are getting all of these observations in your equipment, so what is there for you to handle it? So I believe that would be taken up by my colleague in the next part of the presentation. Here's a poll question for you so that we can understand whether our audience is already experiencing varnish. So do you decide a varnish based on its color? Have you ever experienced it? If you have seen some odd colors in your system, did you identify or did you understand that it's varnish? If you did, then you can mark it yes. But if you could not understand that it's varnish, you probably might have ignored it or neglected it, then you can mark it as no. Please be honest with the response. We'll give you some time to give your responses. So yes, we have the results out here. Pretty good number of people have said yes, which means they have been identifying it as varnish by the virtue of the color of the deposits or those sediments. And around 37% said that no, they could not. So probably we have an audience where we can speak about it. And Guillaume, you will have a nice time to give your experiences, share your thoughts on the further slides. Thank you so much, Guillaume.
Hello, thank you, Anshuman. Thank you very much for these very clear and essential explanations, and in particular the fact that this is not a normal phenomenon, and this is not a phenomenon which should be in any way, shape, or form ignored or neglected. So why is that? First of all, one reason for the risk of varnish is where the deposits will form. And we will go a little bit further into the next slides on how it eventually forms.
Guillaume, you could switch on your camera.
Yeah.
Thank you so much.
Now it's done. Yeah, I just got a pop-up. So it will form in different types of machines. So the types of machines where it is the most relevant are turbo machines like steam turbines, like gas turbines, and the actual type of compressors. So turbo compressors, centrifugal compressors. And another type of equipment where the varnish problem will cause havoc and bring you big problems is hydraulic systems. So it could be large hydraulic machines like automotive or aeronautic hydraulic presses. It can be in injection molding, hydraulic injection molding machines. And it can be also still in the turbines and compressors in the hydraulic controls, which are the peripherals of the turbo machine. Where will we see this pain, this symptom, this disease in the machines? So very often we will see them in bearings. So we can think of turbine or compressor bearings like journal bearings, thrust bearings, and this will trigger particular behavior problems for these parts. We can see it in valves, we can see it in actuators, and then they would be sticky or slow responding or non-responding. So we can see that controlling the equipment becomes difficult and then becomes impossible. In filters, it can accumulate. It can look like a gooey deposit, sticky, gooey, shiny deposit that can clog the filter, and you may start to see filters that need replacing too often, more and more often. You can see it in coolers, and then the part where it will be very often, but you will not necessarily see it unless you inspect it, is the pipeline of the whole lubrication circulation system or the whole hydraulic system. It can also be in seals, and in some types of seals, it will compromise the functionality of the seal. So that can also lead to equipment failure. And finally, it's also very prone to depositing on gear. And this can also, over time, lead to metal fatigue, and then ultimately even breakage and failure. We also saw a photo where a part of the equipment where you will often see it is the reservoir. But I have to say, in the reservoir is the place where it's easiest to see, but it's the least problem. In the reservoir, it will not really cause much problem. But in all the rest of the equipment of the machine, of the lubrication circulation or fluid circulation, it can cause major problem. Okay, so we can move on to the next slide. Okay, and another aspect of that, to go one step further, think of your oil or hydraulic fluid in two ways. First of all, a way which is, I would say, maybe a negative way, a problem elimination way, which is a little bit like a doctor. You spot a problem, you need to do some exams to make sure if the problem is real, where it is located, what are the symptoms, and then make decisions to eliminate the symptoms and eliminate the illness. So that's step one. But then there is step two, which is to be whether or not you have symptoms, be in top health, be in the best health possible. So this applies to us as human beings, right? Even if we are not sick, we will still do things to maintain ourselves in the best of health, like trying to eat proper healthy foods, like yoga, sometimes strenuous exercise, or relaxation methods like playing music or meditation, so on and so forth. There's tons of things we do for health, which we do not to eliminate illness, but really for health itself. For your lube oil or your hydraulic fluid, this is also true. And this is very key, because what can you achieve that way? By ensuring to keep the health optimal all the time is much longer fluid life. So as Anshuman already introduced, we often accept, or almost always, we accept a life of a lubricating oil or a hydraulic fluid, which is much shorter than it can be. So this is our standard practice today. It's a fact of the matter in industry with the existing solutions. But if we only do that, only eliminate some symptoms, and we don't focus on having the longest possible life, how affordable, how cheap does that end up being? So we don't do any extra effort, we just do basic efforts, and then our fluid life is too short. How affordable or how cheap is it to do it that way? Well, first of all, if we change the oil too often, then we will have to buy oil every time, and there's a price to that oil. And some of these oils are expensive, right? Some are not so expensive, some are. It depends on the requirement of the machine. Also, when we change oil, we need downtime to drain and to do some jobs and to restart the machine. So this is downtime. And in some cases, when there is no standby for this machine, it can be lost production. So then that's a big cost. Also, there are operating costs for oil changes. For instance, you may need to do a flush between two oil charges. So that's another cost. Also, not really a cost, but a risk exposure. Anytime you need to go work in a big way on a machine, you create more jobs for people around large mechanical equipment. And this means more health and safety risk and more health and safety exposure to the personnel. So if we take a step back and we do a fair and complete analysis, we can see that changing oils often is very expensive. Okay, so what can we do about that? There's a few key points in terms of mindset when we look at oils and when we look at hydraulic fluids. And one of the key points is education. So one thing is there is progress. There is scientific progress. There is technological progress. And we are finding ways to make in-service fluids last much longer. And that means that all of us will gain from keeping educating ourselves and getting education from others, such as this seminar, for instance, and this seminar series from Mintonia. It's one of the many examples you can find. To stay ahead of the current practice and see how we can improve and see how we can, in our particular instance here, find ways to make fluid life much longer. And then number two, it's a holistic approach. If you want the best life out of your fluids, it's a holistic approach, by which we mean from the first day or from the day that it gets delivered to your warehouse, you start with proper analysis of the fluid. When it's the machine, you need to use the right oil analysis, the right tests. So it makes sense to have all the right tests that you need, not to try to save on not doing this or that test on your oil, because this is a false saving. And then holistic, as you know, means all parameters. So then when you find anything wrong with the fluid based on the analysis, so any type of contamination or varnish, for instance, then you take steps to eliminate it. And then finally, if you do all of this right, then you will still have aging, because aging is a fact of life. It's unavoidable. And what we see in turbine oils and hydraulic fluids, the way that aging happens is that you lose antioxidants. Okay? Antioxidants. The antioxidants are the chemical components, the additives in your fluids, which give it its long life. But the antioxidants sacrifices itself to fulfill its mission over the life of the fluid. And then at some stage, you don't have enough antioxidants left in the fluid. And what you can do at that point is to, in a careful manner, in a compatible manner, without doing any improvisation, which would change the performance of the fluid, you can re-top up antioxidants into the fluid. And by this way, you can double its life, and you can add it many more long years for this. So in many instances in industrial lubrication and hydraulic fluids, we see with our own eyes that when it's done right in a holistic manner, we can end up with lubricants or hydraulic fluids, which will last as long as the machine that they are used in. In fact, yeah, I will still have a couple. In fact, if we do it that way, it's a new way of doing things, but it's a more affordable way than the way that we are currently doing it. So it may be a small expense for a very big saving. On top of that, because we implement the holistic approach, we will see improvement in the reliability of the machine. So that's a big gain. And on top of that, we will avoid completely unneeded industrial waste. So we also take a big step in terms of sustainability, not wasting things that we can still keep using for many years. So these are the mindsets improvements and evolutions which we should keep to the forefront of our minds in order to achieve the longest possible life for our industrial oils and hydraulic fluids. Yes, and now I think we have a quiz question coming up. So have you seen in your industrial life, in your job responsibilities, again, please, we ask you to make this educational and meaningful for all. So please answer honestly this question. Have you seen some servo valve get stuck because of a sticky deposit? So we leave you time to take your time to answer the question. Okay, so we can see we have enough answers, and we can see it's a very prevalent problem. Then this can be a sign that varnish is there and varnish is creating a problem in the machine. So why? Okay, if we have moisture in oil, we understand why. It means water has ingressed into the oil. Or some hard particles can be dust ingress or can be a sign of wear, depending on what the particles are made up of. But varnish is not so intuitive. Where is this thing coming from? So, in fact, there are a few modes of oil degradation that will lead on to this problem. And we can put these mechanisms in 4 big categories. One is oxidation, going from left to right. One is heat, meaning thermal degradation is extra heat, or it can be contamination, or it can be all-inclusive category that we call other. So for oxidation, you need, of course, the presence of air, but be aware that when you take a new industrial oil delivered into your warehouse, it will contain already a significant quantity of air inside the oil, like 10% of air in the oil. That is normal. So you will always have air. Then the presence of metals acts as catalyst to accelerate this reaction. And if the oil is exposed to sunlight, then oxidation will be also promoted by UV, ultraviolet radiation. Then the second category, we have heat. So heat can come from some particular events that happened at the various places, various locations in the machine and its lubrication circulation system. One of them is a spark discharge can happen. So it's electrostatic charge, which will discharge at some point. And this causes extreme heat at the point where the spark takes place. We have also micro-dieseling, which is the result of cavitation, which is implosion of bubbles inside the oil. And this implosion is such that it auto-ignites, it self-ignites, just as the oil droplets do inside the diesel engine. So this causes the creation of very small grains of soot inside the oil, or also, and this we can spot with thermographic analysis of the whole equipment, we can have hotspots in machines that will be too hot for the oil to handle, and this will also cause the kind of degradation that promotes varnish formation. Also, we have contaminants. So some contaminants are very common, like moisture. Moisture is not a very big problem in gas turbines where the oil is hot enough that the water will be evaporating, but in steam turbines, moisture can be a big problem. We can have solids, we can have dirt from the environment or dust, depending also about the whole housekeeping and cleanliness of the surroundings of the machine in the plant. And sometimes you cannot really eliminate all the solids, and you can also have solids which come from poor flushing on commissioning, that you leave some solids behind, or you can have anywhere inside the machine, anywhere will turn into metal particles which are solids. So any presence of contaminants in your oil will promote its degradation. And also, when we're talking about compressors, we are compressing a gas, and in many types of compressors, there are ways that this gas can ingress into the lubricating oil. So it can be depending on the gas we are compressing. If we are compressing natural gas, butane, propane, all hydrocarbons, if they get into the oil, they will accelerate the degradation. It is true also of air, it is true of CO2, of carbon monoxide, even nitrogen. Nitrogen is usually something we think of as a very passive gas. But once it has gone inside your oil and it is dissolved in the oil, it will also create degradation of the oil. And finally, there are other possible forms of oil degradation. So some of the formulation may be unfortunately not as stable as it should be, and some of the additives which are part of the oil formulation that your supplier is delivering to you drop out, and then that is a form of degradation. The general quality of the oil formulations that you buy, they're not all the same. Don't go thinking that hydraulic fluid is a hydraulic fluid is a hydraulic fluid, and whatever you buy, it will be the same performance and the same quality. That's not the case. And same for industrial oils, for turbine oils and compressor oils. They don't have all the same quality. And finally, incompatible fluids, and frankly, all of us here like to think we are infallible, but no human being is infallible. And sometimes we may have human error, right? So a top-up of a wrong fluid inside your industrial oil may happen. And okay, then that's an unfortunate event which will cause degradation of the oil. So as Anshuman said at the beginning, when you have this degradation that leads to varnish, no, it's not a feature of the fluid, of the oil or of the hydraulic fluid. It's a problem coming from degradation, and there are many possible causes of degradation. And if you give it enough time, it's a matter of time when the degradation will become enough that this varnish phenomenon will occur, will take place. Okay, we can move on. So this degradation of the oil does not happen in one step, but it happens in multiple steps. So you have the first stage of oxidation, which is marked as 0,1, which is unavoidable. Oxidation is a fact of life for everything around us. We know that iron can rust. We know that our bodies can be a victim of oxidation. So it's a fact of life. There will be a stage of oxidation. But then there are other stages that develop from that, which can be number 2, polymerization, number 3, solubility, number 3, solubility, stage 3, number 4, precipitation, stage 4, agglomeration, and then you have initial varnish, and then stage 5, actual varnish deposit. In fact, so this gives us opportunities, which means that in every step of the way, if we can break this step to the next stage, we can stop the phenomenon. And if we use the right solutions, we can reverse the phenomenon. So this phenomenon is not one way. If we take the right action steps, we will be able to reverse the phenomenon and remove the varnish and eliminate these undesirable degradation products in the oil. Now we have a new question for you. So varnish and contamination, how far are they the same thing or different things? So can we distinguish between varnish and what we call oil contamination? Is it a frank yes? Is it a no? Is it sometimes or none of the above? Please take part. It's always good to see what everybody's experience has been. Okay. All right. we have enough answers. And it's very important to get your answers, because a lot of how we learn about these things, some part of what we learn is research in laboratories and in bench tests. And some of what we learn is from real life, is from machines before it's too late. So that's why it's so important to get the feedback from you who are in charge of machines. And okay, it's the fact of the matter is some contamination, like hard contaminants, like a particle count, is not varnish, and some contamination can be varnish. So sometimes they are one and the same thing, and sometimes they are not. Sometimes they are different things. So sometimes you can remove some contamination, like water and particles, but you will still have the varnish. So now, okay, we understand better, I hope, why this phenomenon comes. But how can we see if it's coming by analysis? So a very important part of that is you will get on most machines. So some machines don't get any oil analysis. Maybe sometimes it's right, maybe there's no need. Some machines need it and they don't get it. So in that case, it should be implemented that the oil gets sampled on a periodic basis and gets analysis. But also, sometimes it gets sampled, sent to the laboratory, analysis is performed, but lo and behold, and that's a pity, it's even a bit sad, tests that are absolutely needed are not done. So there is a whole operation of sampling, sending, analyzing, writing and printing the report, and getting the report back to the machine and reading and trying to understand how the machine is doing. But this whole activity is largely wasted. Why? Because we haven't done tests that the machine really needs. So in other words, if you go to a doctor because you feel that your heart is beating too hard, you feel something like palpitation, and the doctor says, "Okay, please take off your shirt," and he asks you to breathe. He listens to your breathing with his stethoscope, and then he takes your temperature, but he doesn't do anything about analyzing the heart. Obviously, that would not be satisfactory. If you go for a heart problem, you want the heart to be analyzed. You want an ECG, and you want to get interpretation regarding your heart to understand the symptoms. So it's the same for the phenomenon of oil degradation and of varnish. And you can hear that I'm spending a bit of time on this point. It's the heart of the matter. It's a pivotal point. To avoid this problem, or to catch it early enough that you can still have time to fix it before it gives you a problem in your production, you need to have the right oil analysis. You cannot manage this issue if you don't get the right oil analysis. And we will go straight to the main key tests that are really here to identify this oil degradation itself, which is the chemistries that will eventually turn into deposit, into varnish. And we have two tests on this slide that can do that. One is the MPC test, which is membrane patch colorimetry. So the acronym for that, membrane patch colorimetry, is MPC. It's a color analysis. It's a method that we manage to extract these contaminants from the oil and capture them on a membrane. And then the color of this membrane is read by a photometer, reading color. And so in the end, you get color values, and this tells you what is your presence of these degradation products in your oil. The other method that sees these contaminants is the blue method on this slide, which is called ultracentrifuge. The difference between the two, so they have very good correlation. You can see if you do both, you can see that when MPC goes up, ultracentrifuge go up, and vice versa. The upside of MPC is that, first of all, it's a very affordable kit to do this MPC test, whereas ultracentrifuge is a much more costly investment, much more costly equipment. The other upside of MPC is that it is a standard method, a global standard under ASTM code D7843. So all labs that are accredited for D7843, it means that there is reproducibility between the laboratories. So if you have to send a sample to one lab and for some reason send a sample to another lab, you're able to compare both results because it's a standard D7843 method. So that's very important. So all in all, the test that is needed, that is by far the most commonly used for this problem, is the MPC test. And if you want to protect your equipment from this phenomenon, the MPC test is basically a test you need to have on your oil analysis report. I will still add a few comments on the previous slide. So particle count can be a sign of varnish, especially the very small in the ISO 4406, which has 3 categories. The very small category size, if that is erratic, going up and down, unstable, can be a sign of varnish. So it would be a complement of information. Acid number is a sign of risk, but there is a problem with that test, which is that, frankly speaking, if your acid number has gone up in a remarkable manner, then it's too late. It's too late. It means the problem has become too severe already. So it's a test that is significant, but it's not a very good test to anticipate the problem soon enough. Okay, we can move to the next slide. Water, you always want to know water. So this is what called here Carl Fisher is a water analysis, particularly naturally for steam turbines. So this is a key test. And then you need to understand. Pay attention, it's a little bit different point. You need to understand if you are trying to cure young oil or a old oil, because then your decisions may not be your best decision may not be the same. Imagine if you have a car which is 6 months old and you run into a mechanical problem, or you have a car which is 20-year-old and you're not even sure you want to keep it, and you get the same mechanical problem. Intuitively, you understand very well that your decision-making process will not be the same for a brand new car than for a car which is reaching end of life. Your oil is the same. If it's a brand new oil and you run into a varnish, you may not want to make the same action items as if it's an oil which has reached end of life, and then you may have different options. So how do you know if this is a new oil, young and strong, or if it's an old oil which is reaching end of life? You need to know this. You need to know this. And very often, I would think people who are attending today, in most cases, they don't get a test. You don't get a test in your oil analysis that tells you this. Is this oil still young and strong, or is it old and reaching end of life? There is a test to tell you this. It's the ruler test. It's the ASTM standard D6971. It tells you how old or young the oil is based on the strength of the remaining antioxidants, the strength of the remaining antioxidants. And the antioxidants are protecting all the other components of the oil. So if they are still strong and still near 100%, then you have long oil life. If they are near 25%, then you have short oil life. Your decisions will be very different in both cases. So this is another test that you need. And if there is oil degradation, then the components of these oil degradations for your chemists will be important to know. And this you will know by the Fourier transfer infrared spectroscopy method, also referred to as FTIR. So here we go for the oil analysis. And we can move on. So this is an example of the MPC test. So as I said, the MPC test, you can see the two square photos. These are two photos of membranes with high varnish. If the varnish presence in the oil is low, then the membrane will look more or less white. So you can see with your eye. But to have a scientific value, you apply the photometer to this membrane and you get a reading of the color. This is the method ASTM D7843. And fundamentally, this color that you see on the membrane is the same material, which sooner or later, unfortunately, will go deposit on your metal, like we see in this journal bearing. And then you may see, or you're pretty sure to see, mechanical trouble and cause disruption to your production. Okay, and then the ruler test is the test about oil life, remaining oil life, and it's basically a comparison of the antioxidants in the new oil, in the fresh oil, before you put it in your machine. That is the gray line on this graph, on this curve, in this slide. And then you take a used oil sample, and it will look the same, only the curve has become lower. This is the red line on this slide. And what this tells us is that the same antioxidants are still present, yes, but there are less of them. And then this gives us a measurement value. We can see at the bottom, the amine antioxidant in this sample is down to 76%, and the phenolic is down to 6.6%. And so we know that when we will reach 25% of the amine, it will be time to either change this oil or take action to replenish these antioxidants to increase the life expectancy of that oil in service. So this is a very essential test to understand the condition of your machine and the condition of your oil. That's the ruler test, ASTM D6971. Why do we measure antioxidants? It's good to think by analogies. It helps us to get a better understanding of facts and of life. And the antioxidants of an oil, we can use the analogy of the skin of the apple. Why? Because the skin of the apple is a small portion by weight of the total apple, right? It should be something like 1 or 2% of the total weight of the apple. But when you start having a little bit less skin, like we see the first photo, then the other components of the apple get exposed. So it's the same that happens when your antioxidants are decreasing. The other components of the lube oil are becoming more exposed to oxidation. And of course, there is a stage where there is not enough skin left at all, and then the whole integrity of the apple flesh is degrading very, very fast. So you can keep this image in mind in terms of understanding your action of your antioxidants in your oil. So why do we do these tests? Okay, it's not all chemistry. You need to understand the impact on your machine, because the test in itself is not really interesting. What is interesting is what it means for your machine. So one is to understand the presence of soft contaminants, which can deposit and form this nasty varnish. And so we do that by MPC test, and to a lesser extent, but still with the particle count, the ISO 4406. Okay, and we can also measure the membrane by weight. This is called gravimetric patch test. Okay, this gives us the understanding of how much of these dangerous soft contaminants we are having. Then how is the fluid degrading? We can measure the antioxidant health by ruler, as I have already explained at length. And we can understand what chemistries are being formed. Are they esters? Are they acids? They can be different types of chemistries. This is by FTIR, so you can talk to your chemist. He is on top of this. He can explain to you the degradation products by FTIR. And then compatibility with contaminants. Compatibility with water will be water separation. compatibility with air will be foaming and air release. These are also signs of oil health. All right, so now we know why the phenomenon appears. We know how we can give ourselves more time to react by doing the right analysis. But okay, now let's say the problem has arrived, in spite of all our best efforts. Okay, when a problem arrives, it's not the end of the world, but don't leave it there. If you leave it there, more problems will come and disaster will strike. So if you have the problem, you have seen it with your own eyes, or you have seen it in oil analysis, eliminate it. To eliminate it, we have two types of solutions, and one type is to use hardware, something that looks like a filter. And since the origins of this problem, many types of mechanical filters have been tried, such as depth media filters, electrostatic filters, charged agglomeration filters. These are partially effective. So you will see, if you use those, you will see a drop of MPC Test, and the problem will be somewhat reduced. But there is a problem. It will not be fully eliminated. And this varnish is a tricky bugger. It's not so easy. If you eliminate it all, you're fine. If you leave some behind, it has a way to regenerate itself, to keep degrading your oil, and to come back. So we want to eliminate everything. And to eliminate everything, the best media technology that has been found for this is ESP media. We will show you a bit more how it works. And by the way, this is a approach which has a strong backing from the OEMs, the machinery builders, including Siemens Energy, Solar Turbines, MAN Energy System, MAN ES. So this has very strong backing from key machine builders. So this will help you in your decision making. So we can move on to the next slide. So to summarize, we have this ion exchange resin technology, which we call ESP, which works by chemisorption, which eliminates the problem. It eliminates all these soft contaminants, whatever phase they are in your fluid. Then we have depth media filters, which can help with some of the insolubles and very, very fine particles. Then we have electrostatic oil cleaning, which cannot eliminate the problem fully in mineral oil. Electrostatic oil cleaning can still be useful to this day in phosphate esters, but this is not a topic for today. So none of these technologies are useless. We are just talking about which one is sure to eliminate the problem 100%, and that is the ion exchange technology. And then still, I will look at the fourth bullet point. We have another approach which we will touch on later, which is solubility enhancement. Because if we make your oil a lot more soluble, this will very much help against varnish. So this is something, bear that in mind. We will touch on this point a bit later. Now, regarding the ESP media, it's not a filter, it's not a mechanical filter. So it will not be good at all for hard particles. It is very, very dedicated to the soft soluble contaminants, which can switch between soluble and insoluble, which are the varnish. And so they are little grains, and they work by chemisorption. And we can see already on this slide a photo, the clean resin before you use it, and after use, the used resin, and it has really sucked up by chemisorption the varnish inside all of these grains. It's very efficient and very effective for this purpose, and it can get the job entirely done. So we can move on. These are other photos of fresh resins and spent resin, saturated resin, which means that it has captured all the varnish that it can. Then we change it and we let it keep doing its job. And a big a big part of all this is to choose the right resin blend mix that you can select. Sometimes, depending on what type of varnish you're having and the type of oil you're having, it may not always be the same. And so we have done that a good 1,000 times for the past 12 years, all over the world, in all types of machines, in all types of industries, in all types of environments, be it emerging markets or mature markets, and all climates of the world, tropical, desert, Arctic, everywhere. So based on all this, we have done a lot of research and development on selection and mixing, blending. So we found the most effective and efficient possible media. And on top of that, if we come across a particularly tough problem, resistant problem, we can still customize to make sure to beat it and to win for you. So this is work that we have been doing intensely for the past 12 years to get to the best mix and blend and solution. In terms of applying it, it couldn't be simpler. So this varnish is delivered, this resin is delivered to you inside a canister, which is like a pressure vessel, this metal cylinder you see in the middle. We put this canister inside a pump unit, which looks like a filter. From the outside, you would say it's a filter, but from the inside, because it's resin, it's not a filter, it's not a mechanical filter. This gets connected as a bypass loop to the lube oil reservoir. So we have a suction point from the lube oil reservoir, a return line to the lube oil reservoir, and then we leave this work for enough time that it takes, not only to get all the varnish out of the oil circulating, but also, if we give it enough time, it will dissolve the deposits that are already on the metal. So you can really eliminate the problem A to Z with a little bit, by choosing the right option, the right solution, the best solution, and then please, a little bit of patience. You keep it going, and it can fully eliminate the problem. So this is an example of what I was just saying. We can see here a tough case, a very bad MPC case, and very bad for the machine. The machine was not able to run, and the MPC value was 70. So when you familiarize yourself with MPC, you will understand that 70 is a horrendous problem. And so it was brought back to acceptable value of 15 very rapidly within 10 days. You can see the initial the initial fall, almost like a cliff. But that was not the end of it. So we could cry victory after 10 days. But if we keep going, we see that then it goes back up, and then it goes back down again, and then up again, and then down again. Then in the end, it stabilizes. Why is this happening? Because the cleaned oil, which doesn't have this contaminant circulating anymore, will pick up the varnish from the metal and become recontaminated. So it's a good thing. It's a good thing. It's cleaning up your metal surfaces where varnish is a problem, is a danger. But it shows up as MPC test rising again. So then we keep going, and we have a system cleaning phase where not only the oil is cleaned up, but also the metal is getting cleaned up. And in the end, you can see in the end, acceptable values and flat, stable. And here we have system stabilization. We have gone from a system which was almost impossible to operate to a system which is reliable. The problem is eliminated. So just bear in mind, in some cases, you can count on something like 3 months, not for initial spectacular success, but for deep cleaning and proper elimination of the problem, and a machine which can run trouble-free. Okay, that's a very important slide to understand what is going on when we fix this problem for good. So this is one example of application. Near the machine is the machine that's in the background there, which is operating. We can see a rigid pipe which is going into the turbine enclosure. And this is at a Siemens application, and we have a strong backing from Siemens for this for these solutions, because they have experienced it like us worldwide, all around the world. And they know our solutions will get them out of trouble, or their customers out of trouble if trouble strikes. And then, as I touched on rapidly, that's not it. We can make it faster or more efficient, or even more effective by another approach, which is solubility enhancer. And this is a different way of thinking. It's a new way of thinking, also very effective. Yeah, we can move on. This takes the form of fluids that we add in a small percentage into the industrial oil or into the hydraulic fluid. Yeah, can we move on to the next slide? So this is based on our solvencer technology. With this solvencer chemistry, we formulate different products depending on the purpose. And the main product is Decon. So Decon will make the oil more soluble. So it will dissolve these deposits on metal very fast, and you get a system cleaner. So how do you do that? You simply top up into the lube oil reservoir or hydraulic oil reservoir, a small percentage, 3 to 5%. And you can do that for many different types of oil. Group 1, Group 2, Group 3, Group 4. For the moment, it's available for oils ISO, VG, viscosities 32, 46, 68. And we are coming up with a Decon HD, heavy duty, which will be for high viscosity oils and fluids. And it works rapidly by dissolving oil degradation deposit from metal surfaces. Okay, next slide. And so if we have a mix on the deposit, we have a mix of soluble and insoluble, then some of the insoluble is caught up by a sandpaper effect, because the soluble part is sticky and soft and is holding up some insoluble. And so if we remove, or when we remove the soluble layer, then it will release the insoluble contaminants, and these can go then to a filtration apparatus and be taken out of the system by the filtration. So this can achieve, this achieves a full elimination of the deposits. And another aspect that we see with all of this is, so we have two lines, two curves on this graph. We have the blue, which is the same kind as I showed you on the previous varnish elimination evolution slide, which is the MPC value of the oil. So this oil, the lower that it is, this curve, the blue curve, the lower that it is, the better. And we see, if you look at please the blue curve, we see the same as I showed you before, a very fast drop in the initial phase, and then a bit of a bouncing tennis ball effect. It goes a few times up and down again as we are cleaning the full deposits in the full lubrication circulation system. And then in the end, we win. It's low, it's flat, it's stable, it's reliable. Now I ask you to please look at the red line. And what the red line is the strength of the antioxidants. So please remember what I was explaining before. This is the life expectancy of your oil. If the antioxidant is high and strong, then your lube oil life is long. And if it's weak, then your lube oil life is short. And this is on the right hand scale, please. Okay, so it needs to be close to 100%. And you see what happens to this oil if you follow the red line. When we had a lot of varnish contaminants, then the slope of the red line was steep, meaning that the antioxidants were lost fast. Okay, that's not good. It means short life. And then in the middle period, we see that the slope became flatter. And then in the last oil change, which is this oil which is marked S4GX46 on the right end of the red line, what happens then? It becomes flat because having eliminated the varnish from the system eliminates something that is aggressive against the oil. And when you eliminate that, you spare the antioxidant. So by decontaminating a system, not only do you eliminate mechanical risk, but you also improve oil life and sustainability and being able to keep your oil longer. On top of that, as I explained in an earlier slide, if we want to have it even longer, we can, on a periodic basis, top up these antioxidants. If we do that not by improvising, but in a careful, compatible, verified manner that doesn't unsettle the balance of the formulation. And if we do that, keep the oil pure, eliminates the contamination problem from the complete system, and then be ready to do little top-ups of antioxidants periodically after many years, then we are looking at possible trouble-free Fill4Life industrial oil or hydraulic fluid. And we can see here the mechanical side of things, which is the one that matters the most to you. When we tackled the compressor back in, it's a carbon monoxide compressor back before we intervened, varnish was terrible. This machine could not be, frankly, operated without shutdowns, without unplanned shutdowns. And then after 2011 is after we intervened, and the problem, the varnish after 1 year was almost like 99% eliminated. And now long-term, it's gone. The problems, this machine no longer has this problem. And this is another case. This is a steam turbine driving a nitric acid compressor. And this is the steam turbine side bearing and how it was before using ESP and how it is 1 year after installation. So to all the mechanical personnel, mechanical engineers listening to this, I'll let you have a look at these two photos and identify how differently this machine will run with the first photo compared to how it will run with the second photo. And as Anshuman insisted, when you see this in your machine, the first photo, don't wait, don't expect that you should be able to keep running this machine like this. It's not good, it will get worse. And if we wait long enough, a disaster will strike. There is no need for that. The solution is available. And of course, you need budget to use a solution. That is true. The fact of the matter is, if you can budget it and use it, it will be much more economical than keeping this problem. There you go. We hope to have been clear, but of course, we will have a question and answer session. So I want to thank you very much for your attention and looking forward to our interaction now. Thank you.
Thank you, Guillaume. Thank you for this wonderful session. Thank you, our experts, for this amazing session on oil degradation and varnish removal. I hope our viewers had an knowledgeable session with our experts. So we have a bunch of questions from our viewers, but before that, I would like to announce our upcoming webinar. So the topic for our upcoming webinar is how to combat water contamination and foam formation in lubrication systems. The webinar will take place on 16th of June from 6:30 p.m. IST and 1 p.m. GMT. Make sure you register from the link in the chat box. The link is there in the chat box. You can register yourself before the seats run out. And that's it. So let's move ahead to our Q&A session, Ask Me Anything session. So we'll start with a question. So this question is from Mr. Hussain. Mr. Hussain wants to know, in a case of turbine, varnish occurs on areas subjected to high temperatures, such as bearings. But what are the reasons of varnish formation inside reservoir or sump surfaces in turbines? So I would like to ask Mr. Anshuman to please answer this question for Mr. Hussain.
Uh, Thanks, Supreme, for throwing this interesting question to me. So I believe it's because of the weight of the gooey material that it gets deposited at the tank surface, and because the lube oil or the other lubricant is mostly in the reservoir in a very stagnant fashion. So over a period of time, the deposit starts happening over the surfaces. However, there would be many more reasons to it, which I would like Guillaume to please elaborate on.
Thank you. Thank you. Yes. Well, it's first of all, thank you for this question. It's an awesome question. It's a very key question in this varnish matter. And yes, we have two phenomena. One is hot varnish, which is in the hot parts of the machine, particularly in the bearings, and particularly in the high load areas of the bearings, not just all over the bearing. So that's the hot varnish. Yes. Then we have cold varnish, and yes, it is linked. It is due to molecular weight of the degradation products, as Anshuman said, and also you can compare it to the phenomenon of sugar in your tea, right? You can easily dissolve the sugar in your tea when the tea is boiling hot, and you stir it with a spoon, so it's turbulent and hot. It's dissolved. It stays there. Now, if you leave your tea and you get taken up by another task, your colleague invites you, calls you to a meeting, you leave your tea in your office. When you come back, the tea is cold, and what do you see? You see the sugar that has deposited at the bottom of the cup. That's the same phenomenon. It's just because in the first instance, when the oil is warm enough and turbulent enough, it's the products are dissolved, and then where the oil is cooler and is less turbulent. So typically the reservoir, or also the cooler or heat exchanger, then it will deposit there because of that reason.
All right. So, Mr. Guillaume, I would like to add another question of similar type to this. So this question is from Mr. Neil. He wants to know, can varnish formation happen at low temperature?
Yes, absolutely. Yes, definitely. So the creation of varnish, first of all, the oil, okay, heat is a contributor to causing this degradation in the oil, but it's not necessary. The oil doesn't need to get very hot if there is an aggressive contaminant in the oil, like a gas ingress or other causes. The start of the degradation of the oil can happen even if the oil doesn't get extremely hot. And then it will deposit. So these degradation products are in the oil. The next question is, where will they deposit? So in fact, they are more likely to deposit in cold parts than in hot parts. That's the cold varnish phenomenon. And that's a different phenomenon to the hot varnish, where it selectively deposits in the hottest high load spots in the bearing.
Okay, so the next question is from Mr. Shubham Saurav Rawal. What type of filtration technology to be used to remove varnish? What is the features so it removes varnish which cannot remove OEM filter and physical filtration method? So I would like to ask this question to Mr. Anshuman.
Yeah, so basically we understood regarding this that conventional filters can't actually remove the varnish because it's not just physical separation, but it's basically a molecular level separation which we need to carry out, because varnish is not always insoluble. It's also soluble in nature, and that's the reason why the conventional filters can't handle it. One more important point here is that the size of varnish and the least sized way, it is just 1 micron or less than that. The conventional filters which the OEMs offer start from 25 micron range. So it's way beyond the capabilities of these conventional mechanical filters to remove varnish. So what happens exactly is varnish forms a layer over the conventional filters, And once that happens, they become redundant. So after that, they won't even be able to remove the larger size particles. Rather, they will just get immediately clogged up because the varnish layer will get deposited over the conventional filters. So that's why, first of all, they can't remove it. Second, they become totally non-functional once the varnish formation starts happening in a particular system. Guillaume, you want to add something to it?
No, not really. No. Other characteristics, it's just rephrasing the same thing. Other characteristics of this varnish are that it is soft, not hard, and that it can be dissolved. It is soluble. It switches in its life from soluble to insoluble. When it is in dissolved form, it will flow through any mechanical filtration, so they cannot catch it. So they can hope to catch a part of it, but all of it, they cannot.
So following this question, there's a question from Mr. Mohammad Reza. He wants to know what is the source of spark discharge in oil. So, Mr. Guillaume, would you like to?
What is the
source
discharge?
of spark discharge in oil?
The cause.
Yeah.
The cause is really internal friction in the oil between the layers of the oil as it flows, and so it depends on various characteristics. The oil is more and more susceptible to it. The less conductive that it is, the more susceptible it is. The drier that it is, the less moisture it has, the more susceptible it is. So this is how and why electrostatic charge builds up. If it builds up, it will discharge at some point. So the solution for that is mainly to use filters that are compatible with the material which is compatible in a way that it will not create electrostatic charge during the filtration process. That's the main step that can be taken to reduce this problem.
Okay, sir. So moving on to our next question. The next question is from Mr. Shahnawaz Kareem. He wants to know what might be the reason for greenish varnish formation in steam turbine. So I would repeat the question. What might be the reason for greenish varnish formation in steam turbine?
Yeah, it can be a dropout of some types of additives if there is this kind of color. But I would like to pack this question and verify what can be cause of green and come back to you with a solid answer regarding this.
I also believe it would be because of some bacterial growth which might have happened because of excessive water contamination in the steam turbine, possibly in the reservoir base. Yeah. So it may be varnish. It may be a mixture between a varnish and the bacterial growth happening at the base of the tank. So this is something which is very commonly found in India. So possibly that's why this question has come up.
Okay.
Yeah.
Okay, so the next question is from Mr. Neil. This question is from Mr. Gyo. If we use synthetic oil, will it help to prevent varnish formation?
It can in some cases. Okay, another activity that we have had and that we have done a lot of research and development also with large oil companies and with machine builders is to design a test, a bench simulation of complete oil life, and we have compared all hundreds of different types of industrial oils using that simulation in this bench. Often synthetic oils have very strong performance, but not always. So generally speaking, yes. There are other ways to get very, very strong oil without resorting to synthetic. And so then you have the blend for the decision making, you have the blend between the matter of the performance and the matter of the price. And if you look at the two, the synthetic may not always be the best choice.
I would just like to add here, if I can just reframe the question and instead of preventing, if I can say, prolong. So yes, by synthetic oils, you can prolong the varnish formation because probably they would have better content of antioxidants. And as we know, the absence or sacrificial nature of antioxidants is something which starts leading to oxidation of oil on a long run. So if you have better content of antioxidants in the oil, so of course the oxidation will happen at a later stage as compared to the mineral oils. And thereby the varnish formation also would be prolonged. So instead of prevention, I believe the synthetic oils would certainly prolong the varnish formation.
Okay, sir, talking about antioxidants, let's take the next question from Mr. Kareem. How can user know the compatibility or the appropriate antioxidant added to the oil?
So I believe, Guillaume, it's related to the solvencer products, the decon.
Yeah, to the decon AO product where we can do that. The way to do that is you need to sample this oil, and you need to have a formulation for the antioxidant to dissolve the antioxidant in the oil, which is correct, which will allow the antioxidants to homogenize in the whole oil. And then you need to have a compatibility qualification testing program, which is a good, strong, robust, which can prove the compatibility. And we do that by resting also on ASTM recommendation for compatibility testing, which is ASTM has a guideline for compatibility, which is D7155. So if you do all these things, selecting the right carrier fluid and doing the right testing procedure and using compatibility according to D7155, you can eliminate risk. That's what we do. So, and our experience of topping up antioxidant additives in critical production machines has been confirmed risk-free. We have 100% success doing this. Meaning if we find it to be incompatible, we don't do it. So that's how we keep 100% risk-free. We know when not to do it, and when not to do it, we don't do it.
Okay, sir. I hope this question is answered. Moving on to our next question. Our next question is from Mr. Suryana. He would like to know how to prolong fluid degradation in lubricant system. Sorry. Please give real corrective action what we should do. In case indicating of varnish issue was occur to journal bearing compressor.
So I think this is a straightforward question with regards to how to handle the varnish formation or varnish prevention. So the steps which we talked about in our webinar, and Calphon gave a detailed analysis of how to do it. First, you must start doing the testing of varnish. Second, once you have done the testing of varnish and you have understood about the antioxidant levels, you understood about the varnish levels, you need a corrective action around it. For corrective action, there are certain technologies where ESP, electrophysical separation process, is one of the most prominent ones. And once you do that, after that, in order to have a prolonged life for your lubricant, you need to go for a solvencer product, which is known as decon. And that would certainly help your general bearing of the compressor have a better life without varnish.
Yeah, and you can, so that's all true. And also before you get to that point, you keep your oil as pure and as clean and as dry as possible at all times. So this is also the other range of services that Minimac is very commonly offering. All you can do to understand the condition of your oil and to keep it clean and pure and dry at all time, the more you help yourself.
Yeah.
Okay. So moving on to our next question. Our next question is, so another question from Mr. Mohammad Reza. How much MPC is reliable for detecting varnish? If MPC is high, so we have varnish definitely. He wants to know if MPC is high, so the varnish is definite in the system or not.
Yes. So can I take this one? So
yeah,
the critical value in MPC is 40. So if it's 40, then yes, you have then.
40,
if it's 40, you have deposits, and you're probably seeing other signs in your machines like vibrations, bearing temperatures, loss of cooler efficiency, valves and actuators who are not reacting as they should. So you will see other signs. Then if it's at caution level, between 30 and 40, you may or may not have all these alarms. If it's monitor level between 15 and 30, you may still be okay, but the problem will get worse. So that's the point when you need to decide if you're a gambler or if you prefer to be safe and don't let the problem get worse. And then if it's below 15, below 15 is normal. That's normally okay, except if you have a hot varnishing in a bearing. So sometimes the hot varnishing in a bearing can happen even at low MPC. That is maybe 10% of cases.
Okay, so if you have MPC between 15 to 30, certainly don't go to sleep. You need to wake up at that point.
We like to say, don't let it fester. Don't let it fester. But of course, we know how it is. Then you need to go to, you need to present the case and find a budget. So, but it's a good idea not to just let it get worse with time.
And never try to just change the oil and assume that you are out of the problem.
Yeah, it's a very good point. So if you change the oil, the problem will still be there. You will be safe for a few months, and then you will notice that MPC is high again, and then there will be a lot of disappointment. And why? Because there is already deposit all over the lubrication circulation system. So the new oil will pick up the deposit, and it will reflect as a high MPC. And even worse,
so I'm sure, Guillaume, you might have encountered dozens of compressor users or turbine users who probably thought that the oil volume is not very high. Let me just change the oil and get rid of this. Yeah. And then they did it. And then after 6 months, they came back to you. Or maybe not even 6 months, but rather 2 months.
Yes, it's not a lost opportunity to help for me. It's a delayed opportunity to help. When that to help. Usually, no, but I cannot be happy about that. But of course, we understand that intuitively, we think if we change the oil, things will be better. But for this varnish issue, it's not effective. And also, what you may be tempted to do is change a portion of the oil, change 25% of 30%. And that's a very expensive thing to do. And you may see an effect for a few months, and then the problem will be back again. So it's a good way.
Trust me, audience, if you are changing or replacing your lube, you are actually draining your dollars into the drain.
That's right. That's right.
Okay, so following this explanation on MPC, there is another question from Mr. Mohammed Reza. He would like to know the difference between MPC and VPT.
Varnish potential test.
Yeah, there used to be many tests, VPR, VPI, MPC. Before ASTM finally made a decision about exactly what method is correct. And that is the MPC method, which is D7843. And again, the upside of using industry standard is that all the labs do it the exact same way. So if you ever have a need to use more than one lab, you can compare the results between different labs. If you use a method which is not standard, like ASTM standard or ISO standard or DIN standard, then you cannot compare between labs. So you lose something that may be useful. So now it's the MPC method, which is D7843.
Okay, so looking at the time, we'll take a few more questions and then we'll close this session. So the next question is from Mr. Kareem. Is there any additive that can prohibit free radical formation or removal? So this question is from Mr. Guillaume, I guess.
Yeah, well, it's the idea of the antioxidants. So the best formulations, the ones that are the most resistant to varnish, they have a good, you need to have a good, strong, consistent base oil, and you need to have good balanced antioxidant formulations. And as we said in the presentation, some oils are better at this than others, but maybe not forever. I mean, in some machines, you will not see varnish, so then the oil is fine and effective, and that's good. And in some machines, it's a matter of time, but if you use a better oil, it will come later. Yes, so that's what the antioxidants do. They incapacitate. They neutralize the free radicals. They prevent free radicals from doing any damaging snowball degradation of the oil. And there was a second part to that question.
Is there no? That was the whole question, I guess. Is there any additive that can prohibit free radical formation or removal?
Yeah. No, that's the role of the antioxidants.
So it's time. So we have actually crossed the time for our webinar. It was so interactive that we didn't even get to know when the time crossed. And so I would like to end this session here. And don't worry for the answers that did not had a chance to, our expert did not have a chance to answer live. We'll surely come up with a FAQ document that would have the answer to all your questions. So stay tuned, follow our company page, Minimac Systems Private Limited on LinkedIn, subscribe to our website blogs, so you might not miss any of the latest updates. And thank you viewers for such an amazing interactive session. Thank you experts for sharing such deep knowledge on oil degradation and varnish removal. And looking forward to our next session on water contamination. So make sure you register for our upcoming webinar. The link is in the chat box. And yes, thank you so much.
Thank you for this lively section. You can also contact me on LinkedIn and Fluidtech on LinkedIn. And for India, we are one team with Minimac. So you contact either of us, and we will help you.
Thank you so much, audience. Thank you so much.
Thank you. Thank you for this lively session. Looking forward to another one sometime.
Bye.
Okay.
Thank you. Bye-bye.